Here is the video for the Unit 5 practice test. So concept A is I can calculate the midpoint and midpoint of and distance between 2 points. So number 1 says, what is a midpoint of a line segment with endpoint 6, -4, and 2, 8? So remember the midpoint formula is when we add our x coordinates, so x1 plus x2 divided by 2, and then we add our y coordinates and divide by 2. So 1 plus y2 divided by 2. So the x coordinates are the first numbers, and the y coordinates are the second numbers. So using our midpoint formula, it's going to be 6 plus 2 divided by 2, and then -4 plus 8 divided by 2. So 6 plus 2, that's 8, and 8 divided by 2 is 4. -4 plus 8 is 4, and 4 divided by 2 is 2. So the midpoint is going to be 4, 2. B says calculate the distance between P and Q, use Pythagorean theorem or distance formula. So if we're using Pythagorean theorem, we need a right triangle, and that's going to be a squared plus b squared is equal to c squared. So that's Pythagorean theorem. Or you can use distance formula. So distance formula is going to be square root of x2 minus x1 squared plus y2 minus y1 squared. So for this particular example, since I'm not given the coordinates, I'm just given a graph, I'm going to actually turn this into a right triangle, like so, and I'm going to use Pythagorean theorem. So across the bottom is 3 units, and down the side is 1, 2, 3, 4, 5, 6 units. So now using Pythagorean theorem, this is going to be c, it's going to be 6 squared plus 3 squared is equal to c squared. So remember with Pythagorean theorem, the hypotenuse is always across from the right angle, and that's always what c is going to be. So 6 squared is 36, 3 squared is 9. Next thing we're going to do is add these two together. So 36 plus 9 is 45. And then last thing we need to do is take the square root. So square root of 45 is approximately 6.71. So the distance between the sides is approximately 6.71. All right, number 3, so it says the following grid represents school fields. Mr. Hook started at the corner of the football field at 9:5, so that point is right here. And walked in a straight line to the pool, which is at 2:1. So 2:1 is right here. And then it says at the halfway point, he buried $500. So where did Mr. Hook bury the $500? So for this particular problem, since it's at the halfway point, that means we need to find the midpoint. So using the formula above, remember we're going to add our x coordinates. So it's going to be 9 plus 2 divided by 2. And then we're going to add the y coordinates, 5 plus 1. So 9 plus 2 is 11, and 11 divided by 2 is 5.5. 5 plus 1 is 6, and 6 divided by 2 is 3. So he buried the $500 at 5.53. So we can check on our diagram to make sure that that looks like to be the halfway point, and looking at the picture, that does look like the halfway point. So this distance right here and this distance right here is going to be the same. So problem number 2, it says what was the distance Mr. Hook walked from the football field to the pool? So for this one, we're going to use distance formula or Pythagorean theorem. So since in the previous problem I used Pythagorean theorem, I'm going to go ahead and use distance formula. So for distance formula, we're going to subtract our x's. So it actually doesn't matter the order that you do it in, but I'll do this point as the second point, and this point as the first point. So it's going to be 2 minus 9 squared plus 1 minus 5 squared. And then we're going to simplify it inside the parentheses. So 2 minus 9 is -7. 1 minus 5 is -4. And then we're going to square everything. Remember, when we square things, it's always going to be a positive. So -7 times -7 is 49. And then -4 times -4 is 16. So next thing we're going to do is we're going to add those together. So that's going to be the square root of 65. And then we're going to put that in our calculator. So square root of 65 is 8.06. So I'm going to say Mr. Hooked walked 8.06. We don't know what the units are, so I'm going to say units. All right, so now let's look at concept B. So concept B is I can identify corresponding parts of congruent triangles. So number 1 says each pair of triangles is congruent. Write the triangle congruent statement for each pair. So remember, when we do triangle congruent statements, we need to make sure we match up corresponding angles. So from here, let's just go off of what is marked. So I know that angle M and angle P match up. I know that these are vertical angles, so we can mark these as being congruent. And I know that those angles are match up. And then lastly, that means angle R and angle Q would match up. So writing our triangle congruent statement, I'm going to start on the left. So I'm going to go MNR is congruent. And then we have to go in the same order. So we went red, blue, green. So I need to go red, blue, green. So it's going to be triangle PNQ. All right, same thing with the second example. I'm going to highlight. So angle W matches up with angle W. Then we have X and Y that goes together, and then angle Z and angle Z. So now our triangle congruent statement is going to be the triangle on top. I'm going to call WXZ is congruent to the triangle on the bottom, so WYZ. All right, second part says triangle JKM is congruent to triangle PQR. Mark every side and angle and write congruent statements for all the corresponding parts. So we're going to use the order of the letters to match up our angles. So angle J is congruent to angle P. And I'm going to write my congruent statement. So angle J is congruent to angle P. Then I'm going to do angle K is congruent to angle R. Or K is congruent to angle Q, excuse me. So I'm going to use 2 markings. So angle K is congruent to angle Q. Then I have angle M is congruent to angle R. So 3 arcs. Angle M is congruent to angle R. And then we should also have 3 side statements. So JM matches up with PR. So JM is congruent to PR. Then we have KM and QR. So KM is congruent to QR. And then lastly, KJ is congruent to QP. All right, number 3, it says mark the corresponding parts of these triangles to show the following. So starting with the first statement, AB is congruent to DF. So here's AB, it's congruent to DF. Then I have BC is congruent to FE. So BC is congruent to FE. So make sure you use 2 markings. Now we have angles. So it says angle ACB. So ACB is this angle right here. Is congruent to DEF. So DEF is this angle right here. And then lastly, I have angle BAC. So BAC is going to be this angle. It's congruent to FDE. So this angle right here. Okay. Concept C, I can prove that 2 triangles are congruent. So number 1 says determine if there's enough information to prove that each pair of angles is congruent by SSS, SAS, AAS, or ASA. If they're congruent, then write a congruent statement. So first thing we need to do is look and see if there's anything extra we can mark, such as shared sides and vertical angles. Well, I see that this looks like a bow tie, which means that we have vertical angles. And then from here, let's label things as being sides and angles. So I see we have an angle here, and a side. And then same thing here, we have an angle here, side. So it looks like these are congruent by angle, angle, side. And now we need to match up our side. So I'm going to use a highlighter just to match up what we have. So I'm going to start with angle S and V. And then we have our vertical angle, so angle T. And then lastly, we have R and U. So now to write our congruent statement, I'm going to start with a triangle on the left. So I'm going to say RST. So RST is congruent to UVT. Sorry if that was a jump scare. My dog was barking. Okay, now let's start with, let's look at B. So first we're gonna see if there's any extra information we could mark. So I don't see any vertical angles, nor do I see any shared sides since the triangles are not connected. So from here, let's go ahead and label the marked information. So this first piece right here is a side. This is an angle marking, and that's a side. And then we have the same thing in the other triangle. So it looks like we have side, angle, side. So these are congruent by SAS. And then we're going to write our congruent statement. So I'm going to match up my angles. So I'm going to start with angle A, which is going to match up with angle F. And I know that because it's made by the side with one marking and the side with no marking. So the side with one marking and no marking. Then I'm going to match up angle E and B because they both have one arc, which leaves us with angle C and angle D matching up. So now we can write our congruent statement. So I'm going to say ABC is congruent. So I went red, blue, purple. So I need to go red, blue, purple. So it's going to be FED. Okay, so number two says, suppose that angle B is congruent to angle A. So I'm going to mark that. What information would you need to prove that the two triangles are congruent using AAS? So one thing I see here is that we have a shared side. So it might be helpful to draw these two triangles separately. Right, here's our shared side that we just separated. So let me write down what this triangle is called. This one's PQA, and this is BPQ. And then we know that these angles are congruent. So in order for this to be congruent by AAS, we need an angle that is next to the angle that we just marked as being congruent. So actually this could be either angle. So I'm going to say if angle P were congruent and Q were congruent, then we would have angle, angle, side. And same thing, the other triangle, angle, side. You could also actually mark angle P and angle Q in the other triangle. So the information that we would need to prove that they're congruent, so we would need angle APQ to be congruent to angle BQP to show that they're congruent by AAS. All right. Lastly, number 3, it says list congruent sides and angles in triangle ABC and triangle YXZ, and then write a congruent statement. So first of all, I'm just going to label what we have. Looks like we have 2 angles and a side. So I know that angle C is congruent to angle Z because they're both 65 degrees. I see that angle A is congruent to angle Y because they're both 75 degrees. And then lastly, I see that AB is congruent to YX because they're both 10 centimeters. So those are our congruent statements. And then it says, are the 2 triangles congruent? Yes, they're congruent. And it says, how do you know? And that's using the triangle congruence postulate. So by AAS, because we have 2 consecutive angles and a non-included side. 2 consecutive angles and a non-included side.